All right, guys, let's take a look. Everybody, let's take a look at this. I gotta figure these lights out. If I do this. Doesn't do anything for the glare. Oh. So, real quick, let me get like some votes for which problem on here gave you the most trouble. I'm just curious. Yes?
I don't know, for some reason 2A confused
2A? I agree with you. Anything else gave you the most trouble? Yes.
1A?
1A.
Yeah.
Okay, gotcha. Yes?
3B.
3B. I'm gonna end up circling everybody. All right, that's pretty good. That's pretty good. Okay, let's see. So that very first problem, this is not just true for a specific problem. This is one of the hardest things about mathematics. How many of you guys know more than one language? Okay. How many of you guys learned English as a second language? English sucks. I think you guys might agree with me. It's one of the weirdest languages to kind of get down because we put things in weird orders. The hardest thing to get about a language, normally you can just memorize words, is the grammar, correct? So I always think of order operations as the grammar of mathematics, and that's why it's one of the hardest things to kind of get down. Grammar tells you how to construct a sentence, and if it's after, what does it mean? So in most languages, the adjective comes after the thing, because the thing is the most house white. House is most important, but of course in English we do white house, and that freaks people out, and I don't blame them. What's the saying for the order operations? PEMDAS. Please excuse my dumbass son. That's right. Or one semester, my class came up with this. Please excuse my deficient algebra skills. Right? So whatever you want to remember it as. I have seen teachers teach that multiplication comes before division, and they need to find another job. One of the things, do any of you guys go on the old people Facebook? On Facebook, I mean. Facebook is social media for old people. But I'll see on there, so yes, I'm an old person. I'll see on there, somebody puts a problem, and it's an order operation problem, and everybody's arguing about what the answer is, and a little tear comes out like, so, we could have called this instead. How do you say that? PEMDAS. You sound like you're drunk, right? So I need you to understand. We chose to call it PEMDAS. We could have called it PEMDAS, but PEMDAS is easier to say. So which way should it be written? It should be written like this. Definitely parentheses, definitely exponents, and then either one of these as they come, either one of these as they come. Has anybody ever heard that there is no division? I overheard over somewhere, how do you divide fractions? You guys remember? Like, for example, quick little side note. How do I do like 2/3 divided by 4/9? Yeah, which one?
The second one.
All right, so I am going to request something. Yes, go ahead.
You keep the one on the left, you change the division multiplication, and then you flip the last one.
Keep, change, flip.
Yes.
Okay. I'm going to take just a couple minutes. I'm going to show you why that's true. You with me? I'm about to do something you should never frickin' do. I'm not about to say, this is the way you should do this problem. I'm going to show you why the shortcut works, because that's what that is. It's a shortcut. You guys kind of, I'm about to do some weird ass shit that you would never do, and I don't blame you. But it's just to show you why it works. Because I want to make sure you see it at least once in your life. It's not just stuff to memorize, it's stuff that has to make sense. Okay, first thing you would never frickin' do. How do I write like 2 divided by 3? Can't I write that as 2/3?
Yeah.
All right, so what's 2/3 divided by 4/9? Isn't that 2/3 over 4/9? Okay, don't tune out. You're not gonna have to do this. I would never want you to do this. If you did this, I'd look at you like you're a little crazy. But what I'm doing right now is I'm trying to prove, as I destroy everything. I'm trying to prove why the shortcut works, right? Oh, I see what the problem is. You're way too big. Yeah. There we go. Okay. This sucks. Everybody agree with me? I call this fracception because it's a fraction inside of a fraction. You ever seen Inception? I gotta watch it again with a notebook. But what's the best denominator to have? What's the best denominator to have? What do you wish was on the bottom? No. What's the best denominator to have?
Nothing.
1. Nothing would suck because you can't divide by 0. That's when things go wrong. You make a little black hole. How can I make the bottom 1? What do I multiply a fraction by to make it become 1? I multiply by its reciprocal. So, am I not allowed to multiply top and bottom of a fraction by the same thing? Right? 2/3 is 4/6. Is everybody with me? Because I multiply top and bottom by 2. So I can multiply the top and the bottom of any frickin' fraction in the universe by any frickin' number I want to except 0. You with me? So I'm going to multiply the top and the bottom by 9/4 because the worst thing about any fraction is the fact that it has a bottom in the first place. If I make the bottom 1, do I need to have a bottom? No. So you see how these become 1? What did we just say? 2/3 divided by 4/9 equals 2/3 times 9/4. That is why the shortcut works. Keep, change, flip is the way to remember. But this is why it works. Okay, maybe. This has all been a little side note, but coming back to this problem. So that was me. I forget what even got me here. But coming back to this. Oh, that's what it was. There is no division. There's just multiplying by the reciprocal. There is no subtraction. There's just adding the negative. You guys are all with me.
Yeah.
This is why multiplication and division are on the same level, because they're the same dumb thing. Neither one of them is more important than the other. You do them as they come. You guys with me? Maybe a little bit, maybe not. Okay. So looking back at this problem, the way I like to look at this problem is if I rewrote this without a division symbol, what's the only number that would be on the bottom? Just looking at it the way it is. What's the only number that I'm dividing by? 2. So if the first thing you do is make 2 times 3, 6, now you have a 6 on the bottom. How the shit did you do that? Isn't 2 the only number that would be on the bottom? Isn't 2 the only number I'm dividing by? I'm multiplying by the 3. I'm not dividing by the 3. Do you guys see that? So if you make that 6, it's not fair, in a way. I'm only supposed to be dividing this by 2, yes? So real quick, let me show you a problem that's got a little less going on. So if I had 4 divided by 2 times 8. I can rewrite that. How do I rewrite 4 divided by 2? What's another way to write that same thing? 4 over 2 times 8. Aren't these the same thing? This is definitely not frickin' 16 because 2 is on the bottom, 8 on the top, right? So if you made this become 4 divided by 16, that doesn't make any sense. How did it become? There shouldn't be a 16 on the bottom. 2 is the only number on the bottom. Are you guys with me? Some of you guys are like, I'm in the same room with you. Okay. All right. Coming back to this. So do not make this a 6. That's not fair. It's only the 2 that's on the bottom. So what's the very first thing I do? No question. Parentheses, because that's the P, right? So it'll be 3 plus 2 squared divided by 2 times 3. Next thing, of course, is exponents. So that'll be 3 plus 4. What's the thing I'm going to do last? I should have asked this first question, but what am I going to do last? What's at the ass end of PEMDAS? Addition, yeah. So I'm going to add that 3 at the end. So the 3 plus is just going to come for the ride. What do I do with this piece? As it comes, what's 4 divided by 2? Times 3? 6. Which is? Holy shit. Okay. So we got 9. Good stuff. You guys kind of with me? Has anybody ever had a teacher that told you multiplication comes before division? Okay, good. I'm gonna cry a little less. But I've seen it happen. I've seen somebody say that. I'm like, oh my God, stop. Okay. So what about this dude? What's the very first thing? There's like two things you could tell me right now. Whenever you're simplifying or solving, who remembers what to look for? Yeah, oh yeah. So what's that call you? Distribute. Yeah, so you always look for distribution because the whole idea with this problem is I want to get all my x's together and all my y's together, right? And some of them are currently stuck inside, poor little dude. So we want to break them out. So, sorry. So if I distribute this, what do I get? I'm going to talk more about distribution in a second because some of you guys should be worried about it. Didn't I just break order operations? What does order operations say I must do first? And didn't I just go, well, screw you? And didn't Jeff just say earlier, order operations is the grammar? You know, it's like, okay, Jeff. So I'm going to focus on distribution in a second. Let's just keep going now. Now I've got everything free. So what I normally do for myself is I pick an underlining, okay. So you have 5x minus 2x. 3x, that's crazy. And again, negative 3y plus 10y plus 10y. Okay. You guys get that? Okay. So real quick thing about distribution. And make sure you guys all got it. Alright, so watch this. So if I have, here's a really good thing. Well, no, I'm not going to do that. If I have this, I can do the inside first, correct? So if I do the inside first, what do I get? 4 times 2? That's crazy. Holy shit. Now, if I distribute, it'll still be true because the distributive property is true. Just why the shit would I do it here when I could just make the inside 2? But if I do it, what do I get? 4 times 5? 20. 4 times negative 3. And what's 20 minus 12? Freaking 8, of course, because I'm just putting the numbers together in a different way. Who cares? So math is like, do whatever you want, you humans. If I have this problem, though, why did I pick 4? Can I do what order of operations wants me to do? No. Didn't I just say order operations is the rule? You have to follow it. But if I remember what the 4 coefficient means, can somebody tell me what 4x means? And don't use multiplication in your answer. What does 4x mean? And I don't want to use multiplication in your answer. You're like, I'm going to do with this shit, man. Yes?
4x.
Doing what? Adding. So 4x means 4x is added. What's x plus x? Plus x. Plus x. Oh, so fundamentally, multiplication is repeated addition. That's going to come up later this semester. You guys with me? Multiplication is sort of a process we created that makes repeated addition quicker. If I had to add 7 8 times, I'm not going to freaking add 7 8 times. What am I going to do? 7 times 8 is 56. Kick ass. Okay, you guys come sort of. So that's going to come up later. We're going to focus on multiplication and all that stuff. But right now I want to show you, what did I just say? I just said that 4x is x plus x plus x plus x. What do I have 4 of here? What do I have 4 up here? I have 4x minus 3, so I got x minus 3 plus x minus 3 plus x minus 3 plus x minus 3. And then I can combine these. It's addition and subtraction. They're on the same level. I can put all my x's together, and how many do I get? Holy shit. And then I put all my negative 3's together. Negative 3, negative 6, negative 9, negative 12. So what's the shortcut? Distribution is a shortcut. I don't want to, especially if this is an 80. Screw writing x minus 3 80 frickin' times. I'm going to just distribute because that's what would happen anyway. So now we made distributive property is a shortcut. Okay. I like it. Kick ass. By the way, I do this all the time, so if you don't like it, I'm sorry. But I'm going to show you why certain things that you just accept are actually true. Has anybody ever seen that? Anybody ever seen why distribution works? Okay, good. There are teachers out there that show that, but there's a lot of teachers that don't. You guys, let me just say this. You guys could potentially go on to become somebody's first experience with some really basic math fundamental stuff. I don't want to make you feel like pressure, but you have to understand you are laying the groundwork for that student's future mathematical ability. So the teachers that are inflexible, I had a few math professors that were inflexible. Thankfully, most of my math teachers were pretty cool. So if you're inflexible, so a student does something in a nifty way, but it's not the way you showed, and you're like, that's wrong, you've just shut down that student's creative approach to math. So whenever you're working with a student, you say, okay, let's see what you did that was right, and if they got the wrong answer, see where you kind of lost it, or where would this work, or why didn't it work this time? You guys kind of with me? So if you're really going to teach math or any subject, it takes a lot of work because you have to try to figure out what was the student thinking, what was good in that thinking, and what needs some work. Not just, nope, it's not the way we did it. That creates people that are going to hate math later in life. Because they're going to be like, my approach is completely wrong, when actually their approach could be almost perfectly right. They just had a couple things they got wrong. Okay. So coming back to here. Nobody said this one. I would have thought this would have been the most hated, because normally people really hate fractions. But maybe I have a class full of people that are my peeps. What would you say to somebody whose answer was 4/4? So they got 1. Can you guys see where they came from? And don't indicate anything if that's what you wrote down, because obviously that's wrong the way I'm saying it. What did they think? Just subtract it straight across, right? So how could you show them that that's not right? That's the trick, yeah. You do, but how could you show somebody that you can't just do 11 minus 7 and 12 minus 8? That's 4/4. What's wrong with that? 11 minus 7 is 4. 12 minus 8 is 4. What do you want from each of?
Like make a pie and like cut it out.
I like it. Okay, so you could try to make visual representations of the fractions and show that you don't get a whole. So yeah, that kind of, you can even say this, 11/12. Is that more or less than 1? And I'm subtracting something from that. So could my answer possibly be 1 if I start with something less than 1 and I take some stuff away from it? So that's another kind of like purely computational way, but it kind of relates to your pictures that you could draw. Are you guys kind of with me? This is the stuff that you have to do. This is why teaching math is not easy. You have to see not just that they made a mistake, but what did they do that led them to that mistake so that you can correct it in the right way. So 11 minus 7 is 4. Yes, cool. 12 minus 8 is 4. That's fantastic. But that's not how fractions work, right? Does somebody know why you have to find an LCD? Because that's what we have to do here, right? We have to find a lowest common denominator. Do you know why? You're like, oh, you just tell me, man.
That's just how it does.
So help me out, guys. Help me out. What's 11x minus 7x? 11x minus 7x. 4x. You guys with me? What's 11x minus 7y? Can't do it. It's 11x minus 7y. Leave me alone. I can't do that shit. Yes? Do you see how this says that? This says 11/12. I got 11/12, and I'm trying to subtract 7/8. Are they like terms? So the whole freaking thing about combining fractions is just based on like terms. And you guys know like terms like nobody's business. You know you can only put 4a and 3a. You can't put 4a and 3b together. Yes? We know this shit. So that's all fraction denominators are. If I had 11/12 minus 7/12, like terms. That's like 11x minus 7x. You with me? So I need a way to do something to the fraction that makes the bottoms the same, and the only thing I'm really allowed to do to a fraction by itself is multiply or divide the top and bottom by the same number, correct? So then the whole problem becomes a number game. What can you multiply 12 up to be and 8 up to be so they're both the same number, right? So who got that? Which guy? 24. Okay. So the quick way, 8, 12 are not that bad. If you just start counting by 12s, take the bigger one, 12, 24. Oh, there you go. 8 goes into 24. That's what I can make them both become, correct? You guys can with me? Have you ever had that explained to you? That's all LCD is for, is to make frickin' like terms. It's not a different idea than like terms. All right. So if I multiply this one by First two. And this one back, 3. I'll get 22 minus 21 over 24, which is 124. And why does that physically make sense? I took something that's just under 1 minus something else that's just under 1, and I got a very small number that makes sense. You guys with me? Does that make sense? Okay. So now 2a, I understand. So let me say this two different. How do you say this? Can somebody read? And I wanted somebody to go, I say this. No, how do you say this statement? I'm sorry, one more time. 7 is less than 9. If I ask you, what is 7 less than 9? What's the answer? What is 7 less than 9? 2. So less than is subtraction. Is less than is inequality. That is English's problem. English sucks. I just established that earlier, right? Now English has another problem. 7 less than 9 is not 7 minus 9, correct? You with me? It's 9 minus 7. Stupid English. The less than actually means other way around. Are you with me? So what does this mean then? 5 less than 3. How do I translate that into mathish? 3 minus 5. If you have any trouble with signed numbers, think about money. I've got $3. I owe you $5. They give you all my money. Are you paid off? No. How much do I still owe her? I'm -2. I'm still owing her $2. So you can think about money. Have you guys ever seen the movie Stand and Deliver? No? I highly recommend Stand and Deliver. It's an awesome movie. I know it's about a math teacher. I'm a little biased, but it's kind of amazing. And there's one scene where they're talking about filling the hole. So like, if I'm 3 feet up and I dig 5 feet down, how far below ground am I? 3 feet up and I dig 5 feet down. I'm 2 below, so I'm -2, right? Okay. And these are all things you're going to be teaching this kind of level if you get the courses, the grade levels you hope you're going to get. You're going to be teaching people for the very first time stuff like 3 minus 5. And you have to come up with physical ways to think about it. They're not going to be good with money because they're not going to know money yet. So you're going to have to come up with other ways to do it. You could go going into a hole and then climbing a ladder out of the hole, right? Going in a hole is negative and climbing up is positive. You could do stuff like that. We'll talk later this semester about other approaches you can take with signed numbers. What about this? What does product mean? Multiply. What's the word for division? Quotient, right? And of course, sum and difference are for adding and subtracting. Okay. So, what do I actually have to do first here?
Multiply.
Yeah, it's 2 more than the product of 9 and 8. The product of 9 and 8. And what is 9 times 8? 72. Okay. Is that cool? All right, I like it. And then I hit you with some algebra just because. One of the very last things we'll talk about this semester is algebra, but I just wanted to throw this your way just to see where we all kind of were. Who's got an approach for 3A? Yes. Okay, so the whole idea is to get x by itself on one side, numbers on the other side. So I'm at the point with this problem where I just pick which side do you want the x's on. So who did what next? Yeah.
I added 3 equal sides to.
Oh, okay, so you're focusing on the numbers. Yeah, you could either move the numbers or the letters first. So let's see, if I add 3 to both sides, I've established what side I want my numbers on, right? So now I've got 4x plus 1 equals 5x. So what's in the wrong place? 4x is in the wrong place. Get him over there, and then I'm basically done. Yay! And of course, how do you check that?
Substitute.
Plug that shit. So the way to interpret the answer to a math equation, I'm not trying to make this harder, but I'm trying to get us ready for part B. When this statement is true, the original statement is true. Does that make sense? You just don't hear it said that way too often. When x is 1, then 4x minus 2 equals 5x minus 3. That is when that equation is true. Did anyone get something freaky here? Okay, let's catch up. What's the very first thing somebody told me earlier? When I'm simplifying or solving, what do I look for? Distribution. So what do you get here? 3x minus 6. Be careful. Something somebody could do is FOIL. Is x plus 2 all of it multiplying by x minus 3? No, just the 2. So the x is just sitting there, and the 2 is going to go in there. It's going to make what?
2x minus 6.
Gas. Do I have any like terms on either side? Now some of you guys might have stopped right there and said, okay. If you try to keep going, get your x's together. Don't have to subtract 3x to get them to move on the other side. And to me, this is the funniest thing in the world. When I teach this kind of stuff, and I'm going to tell you in a minute why it's illegal for me to teach this nowadays, but I'll tell you more. When I used to teach this kind of thing, students hate x, but they desperately try to save its life here. X is going to die, correct? Right? And I always find it so funny that students that hate algebra, they're like, I'm trying to save the poor little x. No, Keely's dead. So what do I have now? Negative 6 equals? Now, if I interpret it the same way we just did this, when this is true, then this is true. When this statement is true, then this statement is true. Is this statement ever not true? Every fourth Thursday? No. This is always true. Does anyone know what the answer is then?
X equals X.
All real numbers. If you gave me any freaking number for x and I plug it in, it will work. And of course, what does this say? It says 1 is 3x minus 6 equal to 3x minus 6. Well, it's always true. No matter what x is true. You guys kind of with me? Okay, cool. Okay. All right. Okay, so what did I just say I was going to talk about? Shoot. There's something I was going to do more with, and I forgot what it was. Too bad for me. All right, I'll remember it. I want to get a little. Any questions from that whole thing? Yes.
Sorry, for the second row, where did the 3x come from?
Oh, here?
Yes.
X plus 2x. Yeah. Oh, okay. I want to talk just a little bit about section 2.1, and then I'm going to let us out a little early. So we will do chapter 1, I just don't start with it. Because first time I taught this class, I did chapter 1, and everybody sort of was like, because it's word problems in chapter 1. So I want to start with chapter 2. Can you guys tell me anything about, well, let me start with this. If I ask a very young person to count how many objects there are up there, what do you think they would do? Physically, literally, what would they do? They would point, like they could do.
1, 2, 3.
All right, so now what if the little kid was like 1, 2, 3, 4. There's 4. What did they do wrong? Counted the block twice. Now, a lot of the things we're going to discuss in here are not things you're going to teach to your students. They are related to why your students make certain mistakes or how they think about things. Are you guys with me? So we're going to get a little deep into set theory. Because what's happening here is, it's called a one-to-one correspondence. Oh shit. So we have a set of numbers, correct? We have a set of natural numbers. You guys ever heard natural numbers? Natural numbers are things that came naturally to us. 1, 2, 3, right? There are entire civilizations that did not have a symbol for 0, for example. Babylonians, for most of their time on Earth, did not have a symbol for 0. You guys with me? That's really weird for us, but every damn thing we do mathematically had to be invented sometime, yes? And so it just happened to be invented at different times. So certain civilizations didn't have certain things. I have a set of natural numbers. So when I go to count things, I'm making what is called a one-to-one correspondence between the set of natural numbers and the objects I have in front of me. So if I assign 1 to square, 2 to circle, 3 to triangle, and then I put 4 to square, do you see how that's not a one-to-one correspondence anymore? The square goes with two things, not just one. So it's a very fancy name, one-to-one correspondence, for a very simple idea. I can't freaking count the same thing twice, right? Okay, I like it. Then you get voter fraud, don't cut this. So if I assign 1 to this one, 2 to this one, 3 to this one, that is a one-to-one correspondence, and I get a correct answer. I like it. Could I use the set of whole numbers? Anybody know what the set of whole numbers is? You ready? What number looks like a whole? What number looks like a whole? 0. So all whole numbers is the natural numbers plus the number looks like a whole. I always thought that was kind of fun. So the whole numbers are 0, 1, 2, 3. Would that give me an accurate count if I made a one-to-one correspondence there? So if I do, my God, Jeff, I'm showing off my awesome writing skills. If I do, this is 0, this is 1, this is 2, do I get an accurate count? No, okay, beautiful. So this is very, like analyzing the hell out of this for a very basic idea, because they're not really basic ideas. They're things that humans had to create. So little people are basically going through the entire evolution of mathematics as they grow. Centuries worth of freaking creations of things they are learning as they grow. You guys kind of with me? So this is kind of extreme. So I always find it funny when students go for help and you're doing like this, or you're doing, and then people are like, what kind of method you do? That's basic. And you're like, it ain't basic, brother. This is centuries of shit, so leave me alone. So you guys are going to be discussing how to teach these concepts. The concepts themselves are, of course, stuff we've known forever, but you're thinking these are little people that don't know shit. They blank slate. So they have to kind of develop these ideas, and that's really neat. It's really weird for us, because it's so far removed for us. We can't even put ourselves in the place. You guys can remember when you first started learning algebra, probably, yes? But ain't no way you're going to remember the first time you saw the number 1, right? And then understood what it meant. You can't put yourself in their shoes, which to me is really like difficult. I can put myself in my students' shoes almost all the time in terms of mathematics. Blah, 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 blah. So I have the idea of a set. So this, I'm going to call this set, no, Jeff, let me expect. I'm going to call this set A, and then call this set B. Just to be different than what I said. Okay. Can anyone tell me any relationship those two sets share? Anything common with those two sets? All right, good. So they're all natural numbers, whole numbers. I like it. Good. They both have 3 things. So can I develop a one-to-one correspondence between them? 1 goes to 4, 2 goes to 5, 3 goes to 7. You guys kind of with me? Therefore, the sets are the same size. I love it. You're all like, oh, charades, really? So I would say, are the sets equal to each other? Hell no. Are the sets the same size? Yes. So I'd say they are equivalent to each other. A is equivalent to B. If A was 1, 2, 3 and B was 1, 2, 3, then A would equal B. You guys all like it? And I like the fact that they both are subsets of the same stuff. They're both subsets of natural numbers, correct? What's a subset? I just used a word. What's a subset?
A smaller group of things?
Yes. So give me one subset of the set A.
Like 1.2, 1.4.
Oh, no. I don't have any decimals in there. Yeah. So, like, if I define C to be 1, 2, is that a subset of A?
Oh, yeah.
And why is it a subset of A? Because this set, you can find it in this set, right? I like it. What symbol do I use? Let's see if you guys pull this. The symbol I would use to represent subset, you guys tell me what this sort of looks like. C is a subset of A. Now, of course, I use the letter C, so it looks like a little C. But what other mathematical symbol that came up earlier today does that sort of look like? Maybe one that was sitting out in the sun for a while or something? Yeah, it looks like a less than symbol, right? And that's sort of what subset means. Doesn't subset mean that the first set is smaller than the second set? Are you guys at all with me? Some of you guys are like, what has happened today? The idea of subset hopefully makes sense. It's a piece of a bigger set. If it's a true subset, that means that this one set is smaller than the other one. That's why the symbol kind of makes sense. It looks like a less than symbol that's just been kind of like lost its edge. Yes? Okay. If I have another way I could describe this is like this. What does that symbol look like? Less than or equal to. Right? So this is a improper subset possibility. So could C equal A, this would be true, yes. Or it could be less than A, meaning it's a subset. So, I mean, those symbols are related to the inequality symbols, which is great, because we know the inequality symbols, right? Okay. Let me ask you this. Let me see if you've ever seen this symbol before. Using these same sets here. Let me number some of these. Is for an element of B. Yes. I like yes. So what do you think about this question? 3B. Is that true or false? Yeah, what does this say? 3 is not an element of B. Is that true or false? True, because 3 is not an element of B. Cool. Okay, how you guys doing so far? You might not have worked too much with these set symbols. You've all used the little squiggly lines, I'm sure, at some point in your algebra. The little squiggly set symbols, right? But these little element of, not an element of, subset, that's some shit you might have forgotten or never done, right? So, last little thing, and then I'll let us out. What if I have this? I have set A is C, D, F, W, and set B is D, Z, F. Sure. Do A and B share anything? What do they share? Good. So I want to represent that with a symbol. Why do they share it? This is kind of a weird question. Where's D and F? Where are they? Where's D and F? It is in set A and set B. Wouldn't you say, if I ask, let me ask you a really weird question. Where do those two sets intersect? Where do they intersect? D and F, right? So all the elements that two sets share, I would use the symbol for intersection, the symbol for, let me show you what it looks like. A and B. You guys ever seen that symbol before? So when I ask you A and B, this symbol means and, it means intersection. The answer is anything that is in A and also in B. So what would the answer be? Holy shit. Okay. So this symbol means intersection, it means and. You guys with me? Okay. Real quick, let me make sure about and. Have any of you guys ever applied for a scholarship? Yes, a few of you guys. Have any of you guys ever heard of scholarships? Okay. So back in the day, when I was young, no internets yet. So we had this big ass book in the financial aid office. And you open it up and you start to read, you must be a math major, check. You must have this GPA, barely. You must, blah, blah, blah. And then at the end it would say, you must be 50% Cherokee Indian. Right, because of and. You must meet every single requirement. So and means not only do you have to be in set A, you must also be in set B. You must meet both requirements. So whenever I see an intersection, the answer is always going to be smaller than both sets. Because there's less things that meet both things. Yes? So the opposite idea is called the union. By the way, this symbol, do you see how it looks like an A that lost its middle bar? If it loses a middle bar, doesn't it look like that? And. A for and. Yeah. Union, it looks like a freaking U. You can't beat that shit. And also, if you were like, you or you, just somebody freaking clean the room. You or you, I don't care. You make the symbol U. Hey, look at that shit. So if I say A union B, A or B, the answer can include anything that is in A or in B. So what's the answer? Yeah? C? D? F? W? Z. So just slap them both together. Don't say things twice, right? You wouldn't say who was in the room with Fred and Fred. You already said Fred. So just list them once. So they're kind of like opposite ideas in a way, right? And or. Okay, I like it. Not too bad yet. This is not too crazy. It's a little different. Some of the stuff some of you guys might have done before. But I think it's a good place to stop. I think we'll stop there. So we just barely did a little bit of section 2.1 today. Today was also mostly syllabus and warm-ups and all that kind of stuff. So next time on Thursday, we're going to keep going. I'll try to get as far as I can in chapter 2. Okay. I look forward to this semester. It should be really good.
Can I ask you something?
Yeah.
So, two things. First thing, you know how